favorite people. Welcome back. This is Mrs. Berger, joined by
Mr. Lamb.
And we're going to talk about whether an ordered pair matches an equation. So is the ordered pair found on the line given slope-intercept form?
Okay, so we're going to use the slope-intercept form. So here's our learning target. I can check if the ordered pair matches the equation by variable substitution.
Ooh, variable substitution.
Ooh, that sounds a little bit like algebra.
That does sound like algebra. Good thing we're ready. All right, Mr. Lamb, you take it away on the first example.
Okay, could you give me something to write with?
I sure can.
Okay, thank you. So this is, again, this is the slope-intercept form, and we already know that because we've been using it.
Like y equals mx plus b.
Y equals mx plus b.
Never hurts to see it again.
Yeah, and I like the fact that you wrote it that way because this has a minus sign. And that could throw you off if you didn't think about it.
That does.
So here's our point that we're going to use.
Sorry. Oh.
It's okay, you sent it to me. So now I'm really baffled as what's going on here.
I don't know. I meant to.
Okay, let's just put it up.
I'm just trying to move it.
Okay, you want to put the y equals mx plus b
Oh,
back
no.
up there? She writes so much better than I do.
I know.
Okay, so here we go. So here's our point that we have, right? This is the point that we were given in -3, -12. So obviously we always remember that the first number is the x and the second number is the y.
That's true.
And in this case, what we're going to do is we're going to do a variable substitution. In other words, we have a variable x, right? We don't know what it is. That's what a variable is all about. So we don't know what it is, but this tells us, well, maybe it's -3.
Yeah.
Okay, so we're going to plug in -3 here. Okay?
No, you do it.
Okay, so
I don't know. You're just kind of looking at me. I didn't know how I was going to write
y
it.
equals 5 times -3, right, minus 3. So 5 times -3 is going to give us, well, that's a negative times a positive.
I got you, Mr. Lamb.
You got
5
the
times
calculator?
negative is -15.
So we have y equals -15 minus 3.
Well.
And we could go through the whole bunch of integer operation stuff, but she has a calculator.
Yeah, so that's -18.
So y equals -18. So we're going to come back over here, and if my x is -3, then we just proved that my y is going to be -18. So
wait a minute.
we got a problem.
Uh-oh.
This can't be one of our points.
No.
Because that y doesn't equal -18.
That's right. So that point is not on this line. That point exists somewhere, but not on the line.
Yeah, we'd have a line like this, and it would be like right there somewhere.
Yeah, right? Because on this line, when x is -3, y is -18. So those two things do not match, which means not on the line.
Yep, excellent.
Excellent. I agree, but now you have to think.
Oh.
There we go. All right, so let's use this next one, and maybe I have it now. I don't know. There we go. Weird.
Yep, probably gonna, there it is.
There it is. Okay, so now I want to figure out,
Never know where it's gonna show up.
-4, 16 on the line, y equals -2x plus 8. So again, same thing, y equals mx plus b. I'm going to use that variable substitution, and I'm going to plug in that x to see if I get that y. So let's do it. Y equals -2 times -4. I'm going to plug in the x plus 8. Well,
Ooh, a negative times a negative.
Ooh, a negative times a negative is not positive. So -2 times -4 is +8.
And you didn't even use your calculator.
I didn't, but I did have it handy just in case, because again, there's no shame in this
Oh,
calculator
there's no
game.
shame in the calculator game.
And 8 plus 8 is 16. Well, look, when x is -4 on this line, my y, and I should bring that down to show that my y would be 16, which means yes, queen, yes, this point is on that line.
Very good. So we've proven once that it works. Well, it always works, but once it was on the line and once it wasn't.
Yeah, mine's clearly on the line because I'm obviously better at this. No, I'm just kidding. It just happened that way.
Oh, this one.
Oh, now we got a lot.
This is a little different. So let's see. Does this graph match the list of ordered pairs? Ooh. Now, you gotta be careful here because I know there are tricky teachers out there that a couple of these might, a couple of these might not.
Yeah.
So we want to make sure that this whole table.
The whole table. So could we, Mr. Lamb, just match some of these points to the graph?
Well, we could as long as they match.
Well, that's what I'm saying. So let's go through them, right? So in
Okay, so you show me 0.
I was still talking. It was just weird because I felt like I was still talking, and I heard the
right over the top of her,
Yeah.
which people tell me I do all the time.
Yeah, so just like we've learned, when a lady's talking, I'm still talking.
Ooh.
So, oh, but I can't write, so look. I thought I dropped the mic, but then I had to pick it back up. All right, so here's an ordered pair, 0, -5. So, 0, -5. Well, that one is on the line. So let's check for -2. That one is on the line. 8, +1. Yep, that one is on the line. But look, I don't know about 12. So what do I do, Mr. Lamb?
I guess we're going to have to mathematically do this one.
Okay, fine.
Oh, great. We got fractions, we got multiplication, we got big numbers.
Well, lucky for us, Mr. Lamb likes to do all these
I
things.
do doing these things. So 3/4 times, and we're going to say, well, our x is 12. Okay, -5, and we're going to see if we come up with 3.
All right, so I got your back. 3/4,
Well,
0.75
there you
times
go. Change
12.
it to 0.75 times 12.
That's 9.
So we have y equals, my y's are kind of weird looking, but that's okay.
Okay.
Equals 9 minus 5.
9.
You know what? I can do 9 minus 5.
Okay, I got it just in case.
So I believe y is going to equal 4.
Well, that means
Oh.
that whoever made this.
See, I told you, you got to be careful of those teachers.
Remember,
Because they'll do that to you.
mean teachers are test makers. So when x is 12 on our line over here, y has to be 4. That says y is 3, so no. That table does not match
Even though
this
3
graph.
out of the 4 do, if all 4 of them don't, it's a no.
Then it's a no-go. All right, friends, if this makes sense, you go on and practice. If not, watch that other video, and we'll see you later.
See you later.